In this video, we're going to look at a couple examples related to the difference quotient. Just as a reminder, the difference quotient is a function or an algebraic expression that is defined as this quantity. So the function evaluated at x plus h minus f of x, and that entire thing all over h. Now, what this first part means, the f of x plus h, is that for every occurrence of x, so for example in this function, the only occurrence of x is there, I replace this x with the x plus h. So I have to just put that in parentheses and then simplify, and this ends up being a little bit more algebra than anything. So let's go through a couple examples. Alright, so our first function that we're going to look at is just the function 2x minus 1. So if I'm going to determine the difference quotient, I'm first going to write it out. So f of x plus h minus f of x all over h, and this is going to be equal to, and now just so we can see it, I'm going to put each of these expressions, or substitute each of these expressions in using brackets. So 2, okay, and then remember this says x plus h, so I replace every occurrence of x with x plus h. So I'm going to use parentheses x plus h, and then subtract 1, okay, and then after this subtract the original function, so minus f of x. So that was just 2x minus 1 all over h. Okay, and now I'm just going to do some algebra. I can get rid of these brackets, remembering to distribute the negative, and then do the simplification in here as well. Okay, so I'm going to distribute the 2, and I get 2x plus 2h minus 1. And then I have to subtract, but now remember, this means if I subtract this entire quantity, that means I have to distribute that to both terms. And when I do that, I get minus 2x plus 1 all over h. Okay, and now at this point there's a lot of cancellation that can occur. So I have the 2x's canceling. Oh, I should do this in a different color. The 2x's canceling, and then the 1's canceling. So I'm left with, at the very end, 2h over h. And then I can do some more simplifying. H's are common to both the numerator and denominator, and my end answer is just 2. Okay, so the difference quotient for this function is just 2. Now, if you do the difference quotient correctly, every single time that h in the denominator should cancel. Okay, so chances are if it doesn't cancel, you probably did something wrong, and that might be a good place for you to stop, go back, and rethink your algebra and the steps that you've done so far. So let's go on to another example. Okay, I need some more room here. Let's look at determining the difference quotient for this function. So again, I'm going to write the difference quotient down. So that's f of x plus h minus f of x all over h. Okay, and I'm going to set it up the same way. So I'm going to do bracket, and then minus bracket and bracket all over h. Okay, now again, I have to replace x plus h with every occurrence of x, so I have two places where x occurs, so I'm going to have 3 parentheses x plus h squared. Okay, and then minus, and now you really need to make sure you use the parentheses here, because otherwise you're going to forget to distribute the negative, x plus h, okay, x plus h, and then lastly I just have to recopy the function, 3x squared minus x. Okay, now this first part, there's a little bit more algebra to do. Okay, so let's go ahead and do this. So I'm going to leave the brackets for now, just so we can simplify this part here. So I have 3. Now remember this, what this quantity means is that I have x plus h times x plus h. Okay. And so then if I do that foiling or distributing, I get x squared plus 2xh plus h squared. And then distribute the negative, minus x minus h. Okay. And then, oh, I think I'll do some more algebra and distribute the negative here as well. So I'll do minus 3x squared plus x all over h. Okay, so let's see. At this point, I think I can, drop the brackets and do some more algebra. So distribute the 3. This one ends up being a little bit more algebra than our previous example. So 3x squared plus 6xh plus 3h squared minus x minus h minus 3x squared plus x all over h. Okay, and now in this last simplification, let's go through and see what cancels. 3x squares cancel. I want red. 3x squared. Okay, those cancel. The x's cancel. Everything else stays. So let's see what I have after all that is done. So I have 6xh plus 3h squared minus h all over h. Okay, and now look at this. There's an h, an h, and an h, and an h. So since there's an h appearing in each term of the numerator, and there's an h in the denominator, that's when I can cancel. Okay, so I can cancel this, I can cancel one of the h's here, and I can cancel this. So when I simplify, I get 6x plus 3h over h. This is incorrect. Remember that when I simplify this is essentially division. So I divide an h out, divide an h out. If I divide h by h, I actually get a minus 1, and at the same time, my denominator disappears because I had that division in there. Okay, and guess what? We're done. Okay, so yes, this one ended up being a little bit more algebra than our previous example, but you should still be able to get this h to cancel every single time in the difference quotient, and that's it.